The question of maximum. Using the derivative to find the critical point. Using the critical point, we can create intervals, and then on each interval, we find increasing, decreasing. Using the increasing, decreasing, I showed the first derivative. We will set the first derivative equal to 0 in order to find the critical point. So, step 1, determine critical points. All right, and then that is we factor the common factor, so it'll be 3x times x minus 2 equal to 0. That's we find we factor the derivative to find the critical point. We find 2 points that are x equal to 0 and x equal to 2. Step 2. Determine the interval. We hope to find the increase and decreasing on the interval. All right, so this is the number line. We have negative infinity on the left, positive infinity on the right. Imagine this is the x-axis. We will have a 0. 2, so that is giving us 3 into negative infinity to 0, 0 to 2 to infinity. Right. So Tyler, that's not right. Increasing, that's right. So we would find out each interval whether it's increasing. The first derivative is our tool, and that's actually step 3. We need to know whether the function is increasing or decreasing. That determined by the derivative. So first interval we combine at negative 1, derivative at negative 1 is positive, so increasing between 0 and 2 we have 1 from the derivative at 1 that's negative 3, so that is negative increasing at 3 for the last interval between 2 and infinity. Any value, any value can test it. So plug into 3, it is actually 9. The positive derivative knows increasing. Okay, so that's how we know. So right, increasing then decreasing. So right there at 0 we should have a maximum. Decreasing then increasing. So at 2 we should have a minimum, local minimum. This is a degree 3 polynomial. On this direction, at negative infinity, it goes way down, so it doesn't have a global maximum or a global minimum. Here it's increasing, so it has local maximum, local minimum, or sometimes we call them relative maximum, relative minimum, relative to the point nearby, like the point close to it. It's relative maximum. Everybody got over the questions so far? All answers submitted are correct. That's not right.
Okay, hold on. Sorry.
It's the QR code that was scanned. All right, that's right. This is a question of finding maximum using the first derivative. Any homework questions? I'm hoping that before the test 3 we can finish chapter 2 homework. That way we get sufficient practice. Yes. Yes, the one that we were doing yesterday. I did misspell the word Thursdays yesterday. I was hesitating at the moment. I don't know how. It's a very common word. I think I was just confused. Thursday 4.1. That is about related rates. We're working on. So yesterday we started looking at the quantity in the question for related rate question. And the one thing is to understand the quantity and the relation. Right, when you actually have some kind of concept or some kind of equation that relate the quantity, then we will be able to find the derivative for left side equation and right side equation. And then we go from, we find the rate from there. So related rates, first you have to have related quantity, and then you can find the derivative, which would be the rate. So this question, we have some of the keywords, spherical snowball. So it's a ball, a sphere that we're talking about. We also have diameter, and we also have volume. So these are the quantity. We need to find out if we have the rate, since it's decreasing at a rate. So we have the rate of the diameter. the question is trying to find the rate of the volume. We have to find the relation between the rate of the diameter and the rate of the volume. So it's more or less like a question for physics. But then, but before that, you have to do a little bit of mathematics to think about what's the formula for the equation that connected volume and diameter. And that's what we were doing yesterday at first. That is a volume is equal to, might check it out, 4/3 pi r pi r cubed. Volume is a three-dimensional measure. That's why we have a cube of the variable term. This is just really the coefficient. 4/3 times pi is coefficient. I didn't mention the surface. Surface is the derivative of the volume. So if you take the derivative, it ends up being 4 pi r squared. So 4 pi r squared is a formula for the surface, but it's unrelated to this question. So we're not asking any relation about the surface area. So let's focus on the volume. We do know that we need to find a relation between volume and diameter. This is a radius. Radius is half of the diameter. You get a whole circle. Let's try to review. Okay, so the distance from this and this. All right, let's try and make it straight. All right, so this distance is called diameter. Right. A circle has a center, right? Then from the center to the edge, that's called the radius. So that's the radius. So then, as you can see, radius is half of the diameter. So if we want to find relation between volume and diameter, we kind of have to substitute the r, and we know from the picture that r is half of the diameter, v divided by 2. So we're going to substitute, and we end up having v equal to 4/3 pi times, so we replace the r by d/2 cubed. So now we actually have a formula that has v on one side, d on the other side, and v is calculated using the formula in terms of d. But we are able to simplify this. This is a d cubed, and this is a 2 cubed as a denominator. So this is really d cubed divided by 8. To simplify this a little, just to get a more precise formula, 4/3 pi times d cubed over 2 cubed, which is 8. And we can combine the 4 and 8. 8 divided by 4 is 2. So I have a 2 in the denominator. So 3 times 2 is 6. So if we find out the coefficient is actually pi over 6, that's multiplied by the cube. So that's actually the relation. So you can see that between the volume and the diameter is a cube relation. So three-dimensional measure. So now we can have relation between quantity. V and diameter d. It's now v equal to 8/6 times d cubed. Okay. So we're going to differentiate this equation from both sides of the equation, and here we want to keep track. I did write a little bit too large, but hopefully that made it easy for you to see if you are in the back. That also made it hard for you to find spaces. So we're going to find the related rates that is differentiating both sides of the equation. So once we got the relation between quantity and the rates, the relation between their derivatives. So if you find the derivative of v is v prime, or you can also write dv dt. The time, whenever we find, we talk about rate of something changing is changing through time. As time change, the quantity change. So there's a minute. So our unit per time is minute, but since we have rate of v and rate of d, so on one side we have v prime. That is the rate, that's the rate of the left side, derivative of v. All right, on the other side, we have a function of d. D is the only variable. This is just a coefficient. So to find this derivative, pi over d multiplied by 3d squared times d prime. 3d squared times d prime. So that is the relation between their rates. This is rate for v. You can also write this as dv dt. This is rate for d, right, as dv dt. Well, that sounds awful, dt dt. So obviously the prime notation actually is easier since the d and d have a confusion of notation. All right, now this we actually apply a little bit something that we did in implicit differentiation. D is a function of time, so d itself is not an independent variable. In all our discussion of rates, the independent variable is t. We don't write it out as often, but understand that whenever we talk about rates, per minute, per hour, per second, so the underlying variable is t. Therefore, this is a function, this is a function. There are actually two separate functions. D is the diameter, is a function of time, and V is the volume. Volume is also a function of time. So then this is really the relation between two different functions. We are trying to find the derivatives. Here we are finding the derivative. You have to apply chain rule. You have to apply chain rule. So you find the derivative of the outside function. The cube has derivative 3d squared, and you have to multiply it by the derivative of the inside function. So remember, we gotta apply chain rule. Otherwise, sometimes I have students forget that they are separate. Sometimes I have students write 3 times d prime squared. Sometimes I have students who have 3d squared and they don't have the d prime because they forget the chain rule. So there's a lot of small areas, small possible type or possible mistakes. So we gotta keep track as we go. When you practice more and more, you build your own habit. And hopefully that habit prevent you from making small mistakes. That's what we're trying to do. So what we have here in the question already has some rates. It says here the diameter is decreasing at a rate of 0.2. So we know that the D has a rate that's already given in the question. So in the question, D prime is equal to, it's decreasing, so you're gonna have a negative derivative. Because decreasing is negative 0.2. The unit is centimeter per minute, so the diameter is in centimeter. So it's decreasing 0.2 centimeter every minute. Time is in a minute, so you can put unit here, go negative 0.2 centimeter per minute. And you can also skip that part because we actually are using the same unit for distance, the same unit for time throughout the entire question. All right, and the question is, at what rate is the volume of the snowball decreasing? So the actual question we're asking is, what's the V prime? What's the rate for V? That was what we are supposed to calculate, and now the related rate equation offer the calculation device. So this is what we're gonna follow to calculate V prime. And you can see in the formula, if you want to calculate V prime, you have to have V. You also have to have V prime. D prime there. Rate, penetrating the question, we have calculate what rate is the volume decreasing. The diameter is 10 centimeters. So we also have a diameter value at the moment, the D equal to 10. Right, so have everything ready. We can start calculating the V prime, which goes pi over 6 multiplied by 3, and then times d squared is 10. Then the time is negative 0.2. So this is the necessary calculation. I'm going to leave the pi and calculate everything else. The 6 cancel the 3, so we have a 2 in here. this two cancel the 0.2. We have a 0.2 divided by 2 is 0.1. So that will be a 0.1 times 10 squared. 10 squared is 100 times 0.1, which will be 10. So altogether is negative 10 pi. If we don't combine the pi part with it, I think that should be any question. So the negative already is indicating it's decreasing. So it's decreasing at a rate of 10 pi per minute. That's the decreasing of the volume. Any question? So this will be the first question on the related rate. See if you got the same number on your version of the question. And then this is how you answer the answer. I guess you can try. This question itself already mentioned the word decreasing, so we don't have to put in a negative sign. Right. That's the first related rate question. And then so you can see it is slightly different than previously. We are doing a little bit implicit differentiation there, but there are quite a amount of analyzing going on. So this is this is a skill that we are supposed to practice whenever a question itself does not present a relation directly. So we're going to find out the relation ourselves. This is the second question. I call that the straight line question. Is really the relation between the height and shadow. Right. So then the proportion between height and shadow are the same ratio, so no matter what's the height. A taller person have a shadow, a shorter person has a shadow, a pole have a shadow. Relation between the original height and the shadow, that ratio is the same ratio. So geometrically, if you think of it, since the ratio is the same, we will have similar triangle scenarios. Right, so the straight line is at the top of the 14-foot tall pole. A woman 6 feet tall walks away from the pole with a speed of 4 feet per second along the straight line path. So that's how fast the person walks. How fast is the tip of her shadow moving when she is 35 feet from the base of the pole? So that is basically the question. I mean, even though it says you should draw a little picture to show a right triangle with the vertical side representing the pole and the other end representing the tip of the shadow. Okay. I think I may have a similar example in the file that was under. So that was the one that was mentioned yesterday, a related rate question with answer already in there. I think it does have a street light. This is also a right triangle question. Yeah, this is the one. It's the last question on that example. So a 6 foot tall person is walking away from a 18 feet 10 tall lamp post, straight line lamp post. Just walking away in a real time at what rate is the shadow, the typical shadow is changing. That's really the question. The explanation is similar to what we're doing. And then I think this analyze is going by what rate you were given and what rate you are trying to find out. And then you would start looking at what is the equation for the Latham. That's part A. So the process for all the related rate in this file goes by analyze the given rate, finding out the rate you're given, the rate you're trying to find. You have to find out the relation between these two rates. And you're going to set up the equation and analyze the equation and then differentiate both sides of the equation to find the relation between the rate. Kind of thing. All right, so let's look at our version of the straight line question. As you can see, even with the example from the textbook, we have related rate question. For example, in the textbook, on that file, you also have you see people are analyzing things differently. Even if you have the answer key, and you write out your own solution, you will find out that you're not doing identical things because there are personal learning style and then the way we each person approach a question to try to figure out a way that is comfortable to you. So you don't have to do like follow exactly what the answer giving you or what I am giving you. I'm trying to illustrate a process of getting to the answer from the beginning. All right. So this picture, the question itself really is talking about like a pictorial story. We have it's talking about the lights, street light, and then it says the street light is 14 feet tall. Okay. And then we have a person that's 6 feet tall. So person. All right. Not very good. But this person is what? Well, all right. I guess I'll just write let's take a person instead. Okay, so this is a person that is walking away from the pool. This person is 6 feet tall. That's a good drawing. We also have the ground. The shadow should be casted onto the ground. This is the ground. As you can see, the light. The reason that this person has a shadow is because the light. So the light is casting the top of the person, and then there's a shadow. So it's gonna form a triangle, and this is the light. Right, and then the shadow is by. So this is going to be where the shadow is supposed to be. Try to make it visible. This is shadow. So you can see that there's a right triangle going on. So this is supposed to be perpendicular, but the height of the person and then the ground also have that perpendicular relation. So you got a right triangle, a small right triangle, and you have a big right triangle. There's two triangles because the angle in both triangles are identical. This is 90 degrees, that's 90 degrees. This is the angle at the corner, which is in both triangles, is that angle. So triangle that have the exact same angle are similar triangle. Now, if they have the same side, they will be identical congruent triangle, but they're not. And this one is shorter, which is a shadow, and this is a longer, so it doesn't have the same size, but it does have same angle. Every triangle has 3 angles, 3 sides. So these two triangles, the smaller one and the bigger one, have the same angle but different size. So we do have these ratio. The 6 to 14 are going to be the ratio between the small triangle and the big triangle. How fast is tip of the shadow moving when she is 35 feet from the base? All right, so we are focused on this one, but moving of a single point are not going to be quantified. Moving of the exact measure will be quantified. So what we're going to do is we have call that the origin. So we can measure this. Right, so we're going to call this the x value. So x will be the distance from the base of the pole to the tip of the shadow. So x value, the beginning of it does not move. The ending is moving. So if you find the derivative of x prime represents the rate of change for x. But see, the initial point and terminal point, only the terminal point is moving. So x prime will represent the rate of change of that point because this one does not move. All right, I have students that they made a mistake, they call this one the x, and there will be a problem. If you find out this as your x, then you will have a smaller rate of change because this is also moving. As a person walking that way, so this is moving, this is moving, so the rates of this distance are not going to be the exact rate change of this or that, because it's going to be a subtraction of the two rate of change, which doesn't help for us to find out the rate of change that one. So when you try to identify the tip, so with a certain quantity, your quantity should be the one has a fixed point and a moving point. So try not to label quantity that has a moving point and a moving point for both the beginning and the end of it. Okay. Any question? So there are a lot of distance involved in the question. We certainly don't care about the hypotenuse, because in the question we do have how fast is the tip of the moving. So x prime is definitely something we want to know. Another thing is a woman is walking away from the pole with a speed of 40 per second. This person's foot is moving. So we are trying to, that would be a rate of change for a distance. That's distance from this person to this base. That's how fast this person's moving. So let's call that one the y. Now this is a variable x, y, and let's call this z. From the foot of the light pole to the foot of the person, let's call that the z. And therefore, this side must be the subtraction. So this side is going to be the x minus 3. Any questions? I'm representing this by z because I know the z, this person's moving. So z has a, the speed of the person is 4 feet per second. So we were given this rate that goes, the rate of change for z is 4 feet per second. Okay, and then the question is to find really the rate of the x, rate of the shadow, and how fast is that moving. If you don't mind writing the entire fraction, you can also write dz dt. This is a dx dt that we're finding out. All right, so to find the relation between their rates, you first have to know the relation between the quantity. There is a similar triangle relation. So the ratio between this triangle and this triangle, the height of this triangle is 6 to 14. So we're gonna try to figure out what kind of relation does x and z has. So let's try relation. We intended to in order to create a related rate, we gotta have a relation to the quantity, and that is the quantity in the question, v and x. That is the triangle are similar. I guess we should review a little bit a relation to the triangle. If you got a small triangle and you have a big triangle, and they're similar, meaning they have the same shape, like this triangle and this triangle have the same shape. Then what's going on is let's call that a C. And this is going to be a bigger A. Let's call that bigger A. We use lowercase letter. Right, I would just call that C, D, F. All right, according to similar triangle, the ratio between A to D, their corresponding sides, and B to E, it is equal to the ratio between C and F. Okay, so that similar triangle, that is the ratio between the big and small triangle, that goes A, B, C, and the big triangle goes D, E, F. So the ratio A to B equal B to E equal C to F. That's the similar triangle relation for each pair, two of the similar triangle. the ratio from one to the other, they are going to maintain the same ratio. So this ratio can be called the ratio between small triangle to big triangle. Small to big, small to big, small to big, corresponding triangles. Now we have the same thing here. The small triangle has a height of 6. The big triangle has a height of 14. So we'll have 6 over 14. It is equal to the ratio between the base. For the smaller triangle, the base is x minus z. For the big triangle, this big thing, the base is x. X. And that is a relation between the base and height. We're going to write one more, but it's not going to be useful. The last one is this hypotenuse to this hypotenuse. They will be the same ratio. They both equal to 6 to 14 ratio. Basically, it is 6 to 14 ratio between the two triangles for every size. But for now, we only care about the relation between the distance on the ground. We compare the two distance. This is the distance from the tip to this base. This x is from this tip to this base. So two triangles have different base. So that gives us a relation there. Any question? Right, of course, well, theoretically, we should go ahead, try to find the relation between their rates, but that's, we should pause a little, try to clean up the equation, because if you try to differentiate both on the equation, you end up have to do quotient on the right side. So since we have an equation is different than a single expression. Equation you can maneuver, you can change the division form to a multiplication form. You can change from a summation form to a subtraction form. So there's not a lot of things we can control if we have an equation instead of just a single function, right? So we can cross multiply to turn this equation from a fraction, from ratio equation to a cross multiplication. So we are trying to try to get rid of the fact that we have division. Or you can think of it as multiplying x to both sides of the equation, so times x times x. That way there's no more division. But I want to cross multiply, so there's no fraction either. So we would cross multiply, and then you'll have 6x is equal to 14x minus z. Right. So this is a simplification of the equation to make it easier for the next steps. So determine the relation between the quantity, and then we want to determine relation between their rates. So related rates. Right. So we're going to find the derivative of the right side. 6 is a coefficient, so that just be 6x prime. We're going to find the rates of the right side, and that's going to be 14 times x prime. Derivative of x is x prime. Derivative of z is z prime. That's direct differentiation. It looks a lot less complicated than what will happen if you have a division. And also because these are all degree 1, they're degree 1, so there's no, so for example, derivative of x equal to 1, but then x is a function, so you have to have 1 times x prime, the chain rule. So all degree 1 variable, when you differentiate it theoretically, that will just be the derivative. There's no power, there's no other function related to direct differentiation. Any question? All right, and then you look at what rate we were given and what rate are we trying to find out. The difficulty of this question overall is determining what's the appropriate equation. So once you have the right equation, and the following equation is linear, it's equal to 1. So it's not as complicated once we reach the equation part. We have the z prime, which is 4, right? What we're trying to find is x prime. That is x prime, that's x prime. So focus on solving after we've done that. So try to move it a little bit out. I'm feeling like the space is short. So I have one more line to write down the calculation. Okay, so now that the prime equal to 4, so our equation is gonna look like 6x prime is equal to 14x times minus 4. Okay, and then we have 6x prime. You can do your own solving. You don't have to follow me. Sometimes I do. I feel like you guys can do a lot better. And so that's, and then we move the 656 over, move the 6x prime over, so we will subtract 6x prime. 6x prime. Then the left side will be 0. Okay, then we have 0 on the left side. Equal to 8x prime minus 56. And you can move the 56 to the other side of the equation, which ends up giving you 8x prime equal to 56. So x prime equals 7. All right. So it looks like when the person is walking away 4 feet per second, the shadow is moving away 7 feet per second. So that would be the answer to the question. Do you have any question for the process? Try on your, yeah. It turns out, it doesn't really matter. Just all that matters is visual. So, and you can see from the conclusion that when we are calculating the relation between the rates, we did not have to use the 35. Maybe that means that if you are like 1 feet from the pole, you're walking away 4 feet. Your shadow is 7 feet per second. You're 10 feet away from the pole. You're walking away 4 feet per second. You still have 7 feet per second. So as long as this person is moving away with a constant rate, then the shadow is moving away with some same rate. That's my understanding. Let's say the answer is right. Sometimes the additional information is I wonder if I have to put in the unit. So let me just put in 7. It looks like 7 would be fine. But if we were answering the question in physics or in actual application, we have to express the unit. So it should be 7 feet per second. That's the whole answer. Because it says how fast is the shadow moving. So we should answer the speed or the actual rate of change. Any questions for this? There's another example, like I said, in that file, and when you are working on your version, you definitely are having different numbers. So the main thing is to figure out how to make sense of the process. It's basically a 2-step procedure. First, you try to find a relation between the quantity, and you find the relation between the rates. Then most of the effort is, like for this question, is to analyze how do we come up with that relation. So after you already figure it out, you see there figure 1 equation, so the calculation is not too complicated. The process of arriving at this equation involves understanding the similar triangle and understand how the picture can affect how you identify the relation. We know it's a similar triangle because we draw the triangle. We see there are similar triangles. The 2 separate questions, as you can see, the distance, which is 12, does not affect your answer to the question. All right. Yes. All right. Sometimes the question might give you the relation between the quantity, but then that's the thing as we'll move forward. There are more than one variable. one of the difficulty in relate rates is that we're going away from the common knowledge that we have variable x and variable y. So we are looking at different application. The variables sometimes we name them x and z, and believing some of this solution. Well, different people name their variable differently. So we have p, q, we have u. You can use different variables. And this is a question related to geometry. So we have the notation for volume, notation for radius, and notation for the height of the cylinder. Right. So there are different letters, and that sometimes give people a pressure to handle when there's more than one variable. If this has three variables in the equation, the pi is a number. It's a lot of unfamiliar terms that sometimes causes confusion as we're solving the problem. This is question 3. The nice part of this question is equation is already given. So the relation, the total quantity is given. But the harder part is that for each question, we're understanding relation between different variables. So question 1 is how is dv dt related to dr dt if h is constant? So when it says h is constant, you think of h as a number, and r varies with time. We're gonna find out relation between v prime and r prime when the h is a number. So think of this h as the same thing as pi. Right. And the second question is what is dv dt related to dh dt if r is constant and h varies with time, meaning that h is a function of time, but r is a number. In this case, the r is a number, the h is a function, v is a function. So we can find what's the derivative of them related. The last question is how is dv dt related to dh dt and dr dt if both of them vary with time. So now v is r is a function, h is a function, v is a function. So you have to find how that goes. So the three of them are looking at 3 different scenarios, and they apply to different situations. For example, last time we were talking about dripping water onto the floor. So it's forming a puddle, but because the floor is flat, so normally the water does not build up. So they end up being spread out. So you can think of the puddle it has volume, so it's not a completely flat. So it does have thickness, and that thickness is a constant height, which will be the first scenario when the height is constant, but the height is constant, but the radius is changing. The puddle of water is getting bigger and bigger because the radius is getting bigger. So the first situation applies to that kind of situation. Now the second one is when the r is constant, h varies time. That is when you're pouring water into a cup. All right, so the cup has a constant radius and doesn't change the shape. So you pour more and more water, so water is higher and higher. So that is when the height is bigger and bigger as you increase the volume, but the radius is constant. Last one, it has a variable radius and that variable height. That makes the formula more general. But I would have a hard time imagine something that changes the height and the radius at the same time, and also maintain the cylinder shape. But let's just try to make it more general. All right, so let's try to answer the question. This is a very, very abstract question. As you can see, we don't have a number for h. We say h is constant, but we don't have the actual number. So you have to keep the h in your equation, even though you knew that's a number, but you don't know the number. So there's no number given. So we have to treat this one as a pretty abstract question. But in the meantime, we're looking at different scenarios. All right, so let's see how to answer this question. Right, the relation is already in here. This relation. So we're going to work with that relation. We're going to find the derivative of both side equation. For example, the first question, you're maintaining the h as a number. So that's a number, that's a number. So in the first scenario, v is equal to time. I like to move the number to the front, times h. and then r squared. So if you are trying to find relation between the rates, the derivative of the left side will be dv dt. The v prime is equal to, this is a number, so we leave the number alone. We're trying to find the derivative of the r prime. What's the derivative of r prime? How do we differentiate r prime? What's the derivative of r prime? What's the derivative of r prime? R is it 2r and r prime. Yes. So this is going to multiply by 2r and then r prime. Or we should write the r dt in this question because we were indicated to find the relation between these two, so we're kind of forced to use that notation. Right, so that's pretty much how it's being calculated. So you're going to write dv dt is equal to 2 pi r times h and then times dr dt. It says to enter dr dt as dr slash dt. So we're going to enter exactly that way. So like 2 pi times r times dr t. So that'll be the answer for the first one. I forget to write in the height times the height. Any questions? So there's an interesting fact. 2 pi r is the derivative of pi r squared, right? Now pi r squared, derivative of the r squared is 2r. So you have pi r squared has derivative 2 pi r. Remember, pi r squared is the area of the circle, and 2 pi r is the derivative of the area, right? So I hope that kind of that kind of relation can be. As we lower the dimension, we're slowly differentiating. So area, you got a circle, like my circle, area is equal to pi r squared. So circumference, which was in the PowerPoint example, circumference and radius is 2 pi r. So you see, derivative of this equal to this. Right? The area is 2 dimension and circumference is 1 dimension. This is the distance around the circle. So there's some interesting fact as we try to understand the geometry of circle. So I have 2 pi times the h. That's the answer to the first part. Second part. All right. Second part is when the r is the constant, h is vary with time. So go back to the original equation. Know that r is now a number, so then pi r squared is a number. So the relation should look like this. Change it. Right. Recording. Feel like I clicked on some key. All right. So I'm going to change the color of the presentation. V equal to pi r squared. R is a number. I is a number. So pi r squared is a number. H is a only variable. So that this is a number times h. V equal to a number times h. So if you're trying to find the derivative, since the only variable is h, so the dv dt equal to the coefficient. Coefficient is the number multiplied the variable, so it's pi r squared times the h dt. So that's when you held the r as a constant number and pi is already a constant number, then the pi r squared whole thing is a constant number. And then h is only the variable. If you are trying to find the derivative of h, you'll just take the h dt. H, derivative of h is h prime. It's a relation. So when you try to answer here, you will answer pi r squared times the h dt. That will be answer to the second part. Are we okay? Questions? Let's look at the last part. Last part is when both r and h are function of time. So to think of it better, you can think of it this way. V is a function of time. Okay? And then this is equal to pi times. Now r is a function of time. We write it as r a function of time squared. H is a function of time. So it's gonna look like this. So if you are trying to find the derivative of v, even though we actually prefer dv dt, but instead of dv dt, you can also write v prime t. So the derivative of it will look like this: v prime t. The derivative of the volume is gonna, if you're solving it, you have to do product rule. One function, another function. So according to product rule, you are supposed to differentiate one times the other one plus not differentiate this one and times the derivative of the other. So we're supposed to find product rule, so that the derivative will be like 5 times. Derivative of this is 2 times r t power rule multiplied by the derivative of r. So that's how you differentiate this. Okay, if you write it short, it would just be 2r times r prime. But have the t in place there, give you a clear idea that this is a function. This is not an independent variable, right? And we're going to multiply by h, right? Plus, then this time we're going to keep the pi times r of the t squared. We're going to differentiate the h. The derivative of the h is h prime. So that's how it look like if you were applying product. That's how we calculate dv dt. So I read it this way so we can keep track of those extra things. And also we can keep in mind that this is the multiplication between two functions. That's the reason we apply product rule. Now, if we want to write it into the solution that Weber accepts, we probably don't have that t explicitly, even though it is a function of time. So we'll write 2 pi r dr dt times h. So this part is identical for the first one. So this is really 2 pi r times h dr dt. Now this is going to be pi r squared dh dt, which is exactly what we have in here. So essentially, the last part will be a summation of the first part and the second part. So as you write it out, you're going to see that's what's happening. So right here, we were supposed to enter 2 pi r h and then dr dt. Dr dt is this one. It's dr dt plus the pi r squared and then dh dt. So essentially, the last part is having a summation of these two parts, because the last part is considered both of them being not constant. So we're going to end the part. So we're going to end the pi times r squared and then times d h. The last one is taking this plus taking this. So this is the final answer. It's awful, but it should be dr dt rather than the whole thing over dt. But they can do the same too. I guess if we want to keep it, we should put parentheses so the one that doesn't look like that's on with dt. And let's see if this changed the issue. Okay, so since they're all actually equivalent, but I'd rather have that form of derivative, second derivative. Part A, part B, and then the last part. You can think of the reason. Now, the last one is actually a general form because we don't know which one of them are constant. If they are constant, they would have zero derivative. For example, if the radius, if the h is constant, then dh dt equal to 0. This one is gone. That one was 0, so you have this one in this case. Second case is when the radius is constant. If r is constant, then dr dt equal to 0. So this equal to 0. So that will cause the RD equal to 0. This one goes away. And that's why this one is the only thing we need in part 2, because the RDT, because R is constant, the RDT equals 0. So we can see the last format, the last part C is a general form of the dV/dt. The first two actually are special case. One of the variable is constant. This is question number 3 on the related rates. These are the, well, it's pretty much similar. I think I'm trying to explain why do we have that answer, but there's really not a calculation involved. The only thing that could be a little bit complicated is the product. Any question? So this is question 3 when the relation is given. 1, 2, 4. This is the relation between costs, which is represented by x. Cost is a x value. And then the sale with initial letter S. So this relation represents the relation between cost and sale. If we have higher costs, we should have higher sale. Rate of change of sales, the current weekly advertising cost is $2,000. That means x equal to $2,000. These costs are increasing at the rate of $300 per week. Find the current rate of the change of the sales. The cost is increasing at a rate of $300 per week. So this is X. Dollar is cost in dollars per week. So we're involving one of them. At first I would say cost was in here, sales in there. We'll just find the derivative of sale, which will be rate of sale. But no, this relation displays the relation between X and X, sale and cost. But both the cost and the sale are function of time. So when you see the word per week, so then realize the X is not, X is an independent variable in this equation, but it's not the independent variable in the question we're asking. We're talking about rate of change in this relation with weekly, with the time. That's the thing. So we will try to find this is a relation between the quantity. So we'll find the derivative of their rate. So differentiate the left side and differentiate the right side. So one of the question, one of the things we have to realize with this question is the time. Right. Time. The cost is the X value. The sale is the S number. So X and S, they're both in that equation. The time is not time per week. Time is like the hidden variable. So the X is related to time. Cost is related to the time. The sale is related to time. So they both are function of time. So when you are differentiating this, remember that in behind the thing, like this is in the background, we have this other variable that we have to worry about. We would not have to worry about the relation between the quantity. Relation between S and X is already presented. So the related rates is one we have to work on. That's right. Spaces below. You'll see. The question does give something about the rate. Is the current weekly advertising cost is 2,000. It says cost, so we know X equals 2,000 at one time. All right, and these costs are increasing at $300 per week. So we know that X prime will 300. All right, and we're trying to find out the rate of change of the sale. So we're trying to find the rates of the sale. That's the reason that we have to differentiate it, because we're not finding the sale. If you're trying to find the value of the sale, you plug in the 2000 at the X and calculate this X number. S represents the sale, but if you want to find rate of change of the sale, you're forced to find the derivative. So we will apply this equation. We will find the derivative of the relation for the quantity. We differentiate the left side, which is S prime. Remember, I did not write BSDT. Instead, I just write S prime because this is a lot shorter. Derivative 70,000 is that number, so derivative is 0. You don't have to write it, but I'll just try to follow the process. Then we were supposed to differentiate this. The first part is through 20,000. Is really a coefficient we have to write down. And then we're differentiating the variable part. Derivative exponential function is the exponential function itself. So we have e to the negative 0.0004x. That's the derivative part because of the exponential function. Then we have to multiply the derivative of the inside function. So we multiply this by negative. And we're going to have enough space right in there to like 0.0004. Okay, that's the derivative of the exponent part. So that's the entire thing in the derivative. This part because of the chain. I think I forget something. We should also have x prime, right? The whole reason we do the differentiation. Now x is this is the derivative part of derivative of this. Once we find the derivative of this, remember x is a function of time, so we'll have to multiply this by x prime, which have more space. Move this over so it can actually have space. So let's still have to multiply x prime. Right, kind of with the implicit differentiation, if you have, remember x is a function, s, they're both a function. So whenever you finish differentiating, you also follow by the prime part. This one we have x prime, this one we follow by x prime. All right, so then we can start combining things. 0, you don't have to write it. The negative multiplied by the negative 0.0004. The negative sign is canceled. 320,000 times 0.004. What's the answer? It's a really large number times a really small number. It should be relatively negligible. Yes. 128. So S prime would equal to 128 e to the negative 0.0004 times the x. X is 2,000, so we will multiply by 2,000. And then time x prime. X prime was 300. So we actually have number for this. All right, we have number here. This is supposed to be the 2,000. This was supposed to be 300. So we plug it all in to finish. That's our final calculation for the rate of change for sale. Any question? All right, so the answer is the calculation. So that was the rate of change for the thing. Any questions? This another example when the relation is given. It is question number 5, which the relation is also given, and the question was asking what is the volume is increasing? What's the derivative, the rate of the volume? Was the question. So again, the quantity is already given. So let's finish this one. Overall, we have question section 10. So we're up to number 5. Question number 5. We'll solve this to be our last example. But as you can see, the main idea in related rate is you focus on understanding the relation, figure out relation between the quantity. Sometimes in the question, relation between the quantity is already given. So you'll be working on finding the related rates. That is, remember one thing is all the quantity in the equation are function of time. They're already function itself. So try not to forget to differentiate the variables. So here suppose this first instance in volume is so V is 440. The pressure, which is P, pressure is 93. And the pressure is decreasing at a rate of 13 papa per minute. At what rate is the volume increasing? C, it says C is a constant, so that will just be a number. This will be a question we have to find. Number 5. And so one of the important things is to realize C is a constant number. So that would have a 0 derivative. So let's work it out to see how it's being calculated. Again, the relation between the quantity is already given, so we're going to work out the related rates. All right, so if you differentiate the right side, because the constant has 0 derivatives, so the right side equation gives you 0. Left side equation. Left side is multiplication P times V to the 1.4. If you differentiate the P, is derivative of P, which is P prime. So we have P times time V to the power 1.4. This is product plus. All right, this time we're gonna keep the P but differentiate the V. Applying power rule, 1.4 goes to the front. Just 1.4 V. 1.4 minus 1 is 0.4. And then we also have to multiply by V prime because the chain rule. So that's the differentiation of V prime. And remember we also so that's that finished all the differentiation. Okay, so differentiate P, keep the V, and differentiate the V, keep the P. That's the entire thing. And then anything else, we have the V is 140. We have the pressure is 93. So this is one. This is a 440. The actual question was asking the volume. So we want to ask V prime equal what? That was a question. So that's the only variable that we have to solve. We have the V value. Oh, it's over time. Sorry. The question itself already have P prime and P and the V and V prime. And that will be for today. Sorry. That will be a question. Did you send your searches yet? Are you going to Okay. The bigger question you do have then had that it's supposed to be the first one is differentiation and then thank you. Sorry for the timing. Which is your name?
Yes. Thank you. All right.
Yeah, well, and but there is a trade-off between financial aid and another thing, and so it may be, they want to take the hit now, this semester, and also find out the whole ramifications. If you got two classes, what does that mean? Exactly. Sure. And maybe that you got that letter grade because waiting for the speeches, but if the instructor allows you to make them up and to give you credit for them, then you'd be in a better situation. Sure. Okay. But and the thing to do would be to talk to your instructors for each of the classes and get their comments. If you think I can pull this out, what would you recommend? And if you're out for 4 weeks and they're already how you plan to how reasons that you can be in this situation. It would be good to talk to those